Okay, so today's lesson is solving multi-step inequalities, and the idea is that you're supposed to kind of go through 1 through 8. I'm going to kind of do this with you though, but if we pick two even numbers, let's say, I don't know, 10 and 12. If we were to write an inequality that's true, hopefully we agree that 10 is less than 12. If we were to add -5 to both of those values, well, -5 plus 10 is 5. -5 plus 12 is 7. If we bring down the inequality less than, we still have a true statement. Subtract 3 from the original number. So go back up to 10 and 12. If I subtract 3 from 10, I get 7. If I subtract 3 from 12, I get 9. And it's still true that 7 is less than 9. Go back to the original, multiply both numbers by 2. 10 times 2 is 20. 12 times 2 is 24, and 20 is less than 24. Let's go back to those original numbers. Let's multiply both of those numbers by -2. So when I multiply both of those numbers by -2, I get -20 and -24. But here is the first case where -20 is closer to 0 than -24, so -20 is greater than -24. So I changed the inequality symbol to make it true. Number 6, divide both the originals by 2. Well, 10 divided by 2 is 5, 12 divided by 2 is 6, and 5 is less than 6. And if I go back up and I divide both of the originals by -2, 10 divided by -2, -5, 12 divided by -2, -6. But now I have to reverse the inequality because -5 is greater than -6. So if I take a look, for which of the above did we have to reverse the inequality symbol? And we had reverse the inequality symbol when we were at number 5 and at number 7, because those are the ones when we either divided or multiplied by a negative. So for which of the following did we have to reverse it? It's when you multiply or divide by a negative value. And anytime that happens, you have to reverse the inequality symbol. Write an inequality that represents each of the following graphs. Well, this is showing you that you've got some sort of whole bunch of numbers that are to the left of -2. So essentially x is less than -2, -3, -4, etc. Again, notice that you've got an open circle on -2, which means I can't have -2 as part of my answer. On number 10, I've got a closed circle on the 1 and everything going to the right, which I could say, well, x then is greater than or equal to 1. On number 11, everything is shaded in but the 0. So x can be anything at once on this number line, but it cannot be equal to 0. And then number 12, the entire number line is shaded. So basically what's happening is all solutions are making sense here. And in this case, it's like x being a real number. X equals the reals. The open circle and the closed circle hopefully are nothing new to you. I think you guys did this last year with graphing. So when you start solving inequalities, you're basically doing the same thing as you would with a normal equation. So basically solve like you would a normal equation, remembering that you might have to use a distributive property and or combine like terms on the same side. The part that you have to realize is that if you multiply or divide any inequality by a negative number, you have to reverse the inequality symbol. And that's what we did on the do now, where you saw that those two examples, when we multiplied and divided by a negative, to keep the answer true, you had to flip those symbols. You're going to have to graph. So when you graph, you might want to rewrite the solution so the variable's on the left. That just makes it easier to graph. And then when you graph on a number line, don't forget that open circles are for greater thans and less thans. Closed circles are for greater than equal to's, less than equal to's. Just to be clear, this symbol is less than. It almost looks like it could be the letter L if you straightened it up a little bit, right? And that means this symbol is greater than. So let's see how this works when we start solving some equations. Solve and graph, be careful about the inequality symbol because you might not need to reverse it. First thing I would do is add 2 to both sides. 7x greater than or equal to 42. Divide both sides by 7. You're not dividing by a negative. There's no reason to flip the inequality symbol. X is greater than or equal to 6. Well, I only ask that you show 3 numbers on the graph. Your solution point, a number that's exactly to the left and to the right, as it would be on a number line. The fact that it's greater than or equal to, it's a closed circle, and the numbers greater than or equal to 6 are all the numbers to the right of 6. Let's take a look at number 2. I've got a fraction here. I like to do math. I like to clear my fraction. I'm going to put everything over a 1, and I'm going to multiply the entire equation by 5. 5 divided by 1 is 5 times negative 13 is negative 65, greater than. 5 divided by 5 is 1 times 2x is 2x, and then minus 5 divided by 1 is 5 times 9 is negative 45. I'm going to keep the variable where it is. I'm going to add 45 to both sides. I'm going to get negative 20 is greater than 2x. I'm going to divide both sides by 2. I'm dividing by a positive, not by a negative. I'm dividing into a negative, but I'm not dividing by a negative. It's by a positive variable. So or a positive number. I do not reverse the inequality symbol, and there's my answer. It's negative 10 is greater than x. Well, now here's where you have to be careful when you graph it, because if I decided to read this from the variable first, the variable first says to me, well, x is less than negative 10. These are the same answers. And if you talk about this whole alligator thing, which I'm not a big fan of, but isn't the alligator open up to the negative 10 in the original solution? Isn't the alligator's mouth still opened up to the negative 10 in the rewritten? You did not reverse the inequality symbol. All you did was rewrite it with the variable on the left. It should make your graphing easier because now here's negative 10, a number to the right is negative 9, a number to the left is negative 11. There's an open circle. Where are numbers less than, right? This is less than. Where are numbers less than negative 10? Less than is to the left. Let's try the next one. We've got to distribute here. So I'm going to distribute, and I'm going to get negative 5x minus 20 greater than or equal to 3x minus 12. I'm going to bring everything to the left, variable-wise. Subtract 3x, subtract 3x. Negative 8x minus 20 greater than or equal to negative 12. Going to add 20. And I'm going to get negative 8x is greater than or equal to positive 8. Divide both sides by negative 8. Now here's where you got to stop yourself. You're dividing by a negative. That means I need to reverse my inequality symbol. When you multiply or divide by a negative, reverse your symbol. Final answer should be x is less than or equal to negative 1. Negative 1, 0, negative 2. When I graph this thing, it's less than or equal to. It's a closed circle. Less than or equal to means I have to go to the left. One more example. I've got a whole bunch of fractions. I'm going to do some math again. I'm going to put everything over a 1. Common denominator is a 3. 3 divided by 3 is 1. 1 times negative 2x is negative 2x. 3 divided by 1 is 3. 3 times 2 is 6, so it's minus 6. Less than 3 divided by 3 is 1. 1 times 1 is 1x. 3 divided by 1 is 3 times 8 is 24. This time I'm actually going to bring the variables to the right. No particular reason, just going to do it that way. This turns out to be negative 6 is less than 3x plus 24. If the variables go to the right, then without variables goes to the left. Subtract 24 on both sides. Negative 30 is less than 3x. Divide by, it's a positive 3 you're dividing by, not a negative. You're dividing into a negative. You're dividing by a positive. You do not touch the inequality symbol, and you get x is less than, or sorry, negative 10 is less than x. But again, I want to read that from the variable first. So if negative 10 is less than x, x is more than negative 10. Remember, we're opening up to the x in either one of those solutions. Negative 10 goes in the center, negative 9 goes to the right, negative 11 goes to the left. It's an open circle, and where are their numbers more than negative 10? They're to the right. Okay, so that should be good to take you through the homework. Good luck.